Hi everyone, this is the Radko Tutor here explaining, and in this video we are going to look at Science Paper 2 2022 Physics section. So we are on the Physics section where we are answering question number 9. So we are answering question number 9, and in this case we have our first question there which says define half-life. So what is this half-life? Half-life is defined as the time taken for a radioactive isotope to decay by half. So time taken for any radioactive isotope to decay by half is what we call as half-life. So what I mean is, if you have a radioactive isotope like this, and we make an assumption that this radioactive isotope is decaying. So if this is decaying, meaning that the time that it will take for it to decay by half. So if it is decaying, remember decaying meaning that it is decaying starting from, so it is going like that, it's going like that. So that time that it will take for it to decay up to halfway of it is what we call as half-life. Alright, so this time that it will take for it to decay by half is what we call as half-life. So let's make that in writing. So we are saying that half-life is the time taken for a radioactive isotope to decay by half. So that's how you can define half-life. We go to question number 9A2, which says iodine. So we have our iodine, which is having a mass number of 132 and 53, decays by emitting a beta particle to produce a new element Xe and a gamma ray. The question is, write an equation for this decay. So how can we write an equation for this type of decay? So basically we have three types of decays. We have the alpha decay, beta decay, and gamma decay. So now in this case, the type of decay that we have in our question is a beta decay because of the beta particle which is being emitted. So this is a beta decay. So when something is emitting a beta decay, what we are supposed to know is you have your iodine, which is this one. So your iodine is I, mass number is 132, and the proton number is 53. So if this one is undergoing beta decay, what will happen is that you just need to create an arrow. So make an arrow like that, and then write your new particle which has been formed. Then the new particle that has been formed here is Xe. So you need to write that Xe, which is here, so you write Xe. Now, since this one is undergoing a beta decay, meaning the proton number must increase by 1 and the mass number remains the same. So that's what we do when something is undergoing beta decay. So what we are going to do is that our proton number, which is 53, is going to increase by 1, which is going to give us a 54. And then our mass number, which is 132, is going to remain the same, which is 132. Then you say plus the beta particle which has been emitted, so which is beta, and the gamma that is being mentioned here, because they are saying that it is producing a new particle and a gamma ray. So you need to write that gamma, which is given by the symbol Y. Alright, so that's how you can be able to get the 2 marks from this iodine, which is emitting, or which is undergoing decay by emitting a beta particle to produce a new element Xe and a gamma ray. So that's how you should be able to do that one and get the 2 marks. Alright, let's go to question number 3. So question number 3 says, give one property of a beta particle. So give one property of a beta particle. So this one you say, a beta particle, so this one you say that a beta particle can exist in both positive charge or negative charge. Alright, so that is how you can state the property of a beta particle. So there are so many properties of a beta particle, but I've just given you one, which is that a beta particle can be a positive charge and it can also be a negative charge. So it has no specific charge. It can either be a positive, again it can also exist in a negative form. So that is how a beta particle behaves. Alright, let's go to question B Roman numeral 1. So question B Roman numeral 1 says, mention one medical use of radioactive substances. Mention one medical use of radioactive substances. That is also 1 mark. So we are doing this question here. Now, one of the uses of radioactive isotopes or radioactive substances is to treat cancer. So that is the simple answer that we've been using or that we always use. Alright, so it is to treat cancer. Okay, so it can be a thyroid cancer, it can be skin cancer, it can be, so mostly we use it in skin cancer treatment. Alright, so you can just say it is used to treat cancer. Alright, so that's how you're supposed to answer that question. Now we go to the last question. Now the last question, what I want to do is kindly do this one as your task. So I want you to do this question as your task, and it reads, explain the effect of radioactive substances on the environment. So I want you to explain the effect of radioactive substances on the environment, and please feel free to send your work on my WhatsApp for me to affirm if what you've done is correct or not. Alright, thank you so much. Let's end here for today. See you next time. But please don't forget to follow my Facebook page and also subscribe to my YouTube channel for more videos.